Hello guys, I am Bysisa. So our today's episode is going to be on conventional catalytic simulation. So this is a problem statement giving a carbon monoxide and water as feed stream are combined in the mixer. Then the combined water stream are fed to a separator operating at an atmospheric pressure with 90% conversion, in which the upper stream is cooled at 210 degrees Fahrenheit, while the lower stream is cooled also at 210 degrees Fahrenheit respectively. So in which the carbon and hydrogen gas is produced. So the temperature, this is the operating temperature. Initially water stream is operated at 276 degrees Fahrenheit. Also the same thing with carbon monoxide, up to the last composition, in which for carbon monoxide is 90%, then for water stream is 100%. So this is a typical example on combustion reaction, in which carbon monoxide react with water to produce carbon dioxide with hydrogen gas. So let's proceed to the high-C simulation environment. So as usual, we'll now go to create new. So we add our component. So I have 4 components. The first component is carbon monoxide. Carbon monoxide reacts with water to produce carbon dioxide with carbon. This is our carbon dioxide with hydrogen gas. So don't forget, this is a combustion reaction in which carbon monoxide reacts with water to produce carbon dioxide with hydrogen gas. So here in the name, in the search bar, you either type the name of the component or its synonyms or its chemical formula, so that you can add it as your component. So we now proceed to plot package. So let's choose pentachlorine for the equation of states. As usual, a green color will be shown at the bottom of the interface, identifying that a certain equation of states has been selected as fixed at a fixed conditions. So let's go to reaction. Since it is combustion reaction, so we add our reaction. So here you add your reaction. Then you choose the type of reaction you are going to conduct. So in this episode we are going to consider combustion reaction. So this is our combustion reaction, then we add. So don't forget, CO react with water to produce CO2 with hydrogen gas. So the reactants are consumed while the products are produced. So that means the reactant are going to take negative sign. So negative one also. Then in the product we have positive, since they are produced, while the reactant are consumed. So let's consult back to the question. So the question says 90% combustion. So this is 90%. So after this, we now proceed to simulation. Then you add it to fluid pipe. So after this, we now proceed to the simulation. So don't forget, we are having two reactants. The first reactant is water. The second reactant is CO. So let's introduce a valve for controlling. Each stream should possess its own valve. So this is my for water. Let's call it control 1. Let's call this one to control 2. So let's consult the question again. At water stream, I have a temperature of 176 degrees Fahrenheit and a pressure of 58.78 psi. So I have a temperature of 176 degrees Fahrenheit then a pressure of 58.78 in psi. Then molar flow rate of 100 kg/mol per hour. Then the composition, let's consult the question again. The composition is 100%. So let's water, this is my water. Composition is 100%. 100%, that is 1, because 100% is something as 1 by 1. So we now go to carbon monoxide. The same thing, I have 176 degrees Fahrenheit. I also have a temperature, a pressure of 58.78 in degrees in psi. Also I have 100 kg/mol per hour, the fluoride. Then the composition here I have 90%, that is 0.9. So after this, we now introduce a mixer. So after this, we now introduce a mixer. Let's call it mix 1. So we now go to the mixer. Don't forget the temperature is 176 degrees Fahrenheit. So we now proceed to the other part of the question. So after that, then this it says the combined stream are to be fed to a separator operating at an atmospheric pressure with 90% combustion, in which the upper stream is to be cooled at 210 degrees Fahrenheit, while the lower stream is to be cooled at 210 degrees Fahrenheit respectively, in which carbon dioxide and hydrogen gas is produced. So let's go and introduce our, let's see, the temperature is been raised, okay, decreased along with the separators. So here initially I have a temperature of 176 degrees Fahrenheit, and here after certain unit has been processed, the temperature would increase to 210 degrees. Is cooled to 210 degrees Fahrenheit. That means a heater has been introduced to raise the temperature from 176 to a particular temperature. That is for now, it is unknown. Then later it was cooled to 210 degrees Fahrenheit. So let's introduce our heater. Inlet, I have mix 1. Outlet, let's call it heated stream. Let's call it heat in. Then we now introduce our separators. This upper stream, lower stream. Now let's add our reaction. Let's check for confirmation. Heated stream. let's see, the temperature is 320. Let's see also the pressure to be 6 atm. So we now introduce our coolers for upper stream and also for lower stream. This is for upper stream. And the temperature is cool to 210 degrees Fahrenheit. Let's say the pressure to be 5 atm. That is lower. Let's say the temperature is to be 210 from the question in degrees Fahrenheit. The pressure to be 5 atm as I inserted for upper stream. So this is it, how to solve any question regarding any problem statement concerning aspirin hydrogen based on combustion reaction. So initially I was having two reactants, carbon monoxide and hydrogen. So they are converted to form carbon dioxide with hydrogen gas. So the combustion rate for the reaction is 90%. Is approximately 90% of carbon monoxide is converted to within the process is converted. So let's check for the material stream for upper stream. Let's see what we obtained from the equation of state. Let's see the composition at upper stream. I have carbon monoxide 0.5, 0.05. That is also at water I have 0.5, carbon dioxide I have 0.45, hydrogen gas I have 0.45. So let's check at liquid at lower stream. Composition, typically they are the same. So after lower stream has been cooled, The temperature is has been cooled at 98.89 degrees Celsius and 506.6 kilopascal. So this is it, how to solve any question related or regarding combustion reaction. Make sure to subscribe the channel for the upcoming videos. Thank you for watching. See you in the next one.